Find the area that lies inside both curves. A little bit of a different twist here. R equals 3 plus 2 sine theta, and R equals 2. Area that lies inside both curves. Okay? So to be counted here, it's got to be inside both of our curves. All right. Well, looking at it here, 3 plus 2 sine theta. The R equals 2 is the easy one. What's the R equals 2? It's a circle, isn't it? The radius is 2, so it's a circle, radius 2. So sometimes getting exact little yeah, I got pretty good right there. All right. Okay, so we have 3 plus 2 sine theta looking like this. Something like that. And then R equals 2, yeah, that's the circle radius 2, which is not quite as big as that, but it's something like this. Well, come to find out, so we're looking at this area right in here. That's what we want. That's inside of both curves, because this part is not inside the circle and this part's not inside that cardioid sort of shape. That's what we're looking for. But let's think about what that actually is. Isn't that 2 pieces here? Because think about how this graph is made. This is actually made up of 2 parts. It's this right here, and then that other little piece. Well, think about that. That's then this area, which is the area of the R equals 2 circle from here to here. So I'm going to sweep out that part from there to there. And then I'm going to take the cardioid shape and go the rest of the way from here to here. More or less. Okay? All right. But again, one other thing this depends upon is the points of intersection. And so I need to set those equal to find that. Subtract the 3, 2 sine theta is -1/2, -1, and then divide by 2, sine of theta equals -1/2. And so the theta there we're talking, well, reference angle wise we're talking 1/2, which is pi over 6, but I want it to be -1/2, which is in quadrant, like we said, quadrant 3 and 4. So quadrant 3 angle will be pi plus pi over 6. So the reference angle here, pi over 6. And so the actual ones I want would be, or different various ones, but let's see. So this quadrant 3, if I'm talking about 0 to 2 pi, would be pi over 6. No, 7 pi over 6. Sorry, pi plus pi over 6. Yeah, my math's a little off here. 7 pi over 6. And then if I went, again, 0 to 2 pi, this would be 2 pi minus pi over 6, which that would be 8 pi, so would be 12 pi over 6, so it'll be 11 pi over 6. Okay? If I want 0 to 2 pi.
Could we also just use the negative?
Okay, yeah. Negative pi over 6, we might, that might need to throw that in. Huh?
Then we can go from negative pi over 6 to 7 pi.
Right, okay, yeah. Now, here is something we need to think about too. Yeah, for this part right here, I'm with you there. To get that part, I think I'm going to have to use the negative pi over 6 to the 7 pi over 6. That would sweep it from here all the way over to there. That's what I want to do for that one. I'm with you there. So let's just show this part I'm talking about. So it'll go from here around to here. I'm going to go from theta equals negative pi over 6 to 7 pi over 6. That would be the quadrant 4 angle. Also could say is negative pi over 6. Yeah. Okay? So that area would be the integral from negative pi over 6 to 7 pi over 6 of this curve. So it's 1/2 r squared d theta. That's going to be nice, at least. But then I have the other piece, which is the little bit of the cardioid here. From here to there, how am I going to get that? Well, I can't very well go, because if I went from negative pi over 6 to 7 pi over 6, that would give me that. I want the other. That's where we're going to have to use the 7 pi over 6 and 11 pi over 6. With me? And that's 1/2 of this curve, and that's not going to be as nice of an integral. But that's what it is.
Now on this side, we'd have to use a negative, because otherwise we'd be doing it.
Yeah, I couldn't use the exact same ones either way. Yeah, if I went from 7 pi to 11 pi over 6, that would give me this piece, wouldn't it? And that's not the piece I want. I want this upper piece. So, yeah, we're kind of, it's 7 pi over 6 there. Pretty much that's what we're going to have to do with these. This would be 1/2 of 4, so that's just 2, isn't it? Negative pi to 7 pi over 6. And then this, well, we're back to the square that whole thing out. And so that's 9 plus 6 sine. 6 sine would be 12 sine theta. And then 4 sine squared. And then multiply that by 1/2. So that's going to give me 9/2 theta plus 6 sine theta plus 2 sine squared. D theta. Where did this theta come from? That's just 9/2. Sorry about that. 1/2 times 9 is just 9/2. I think I was doing the antiderivative as well there. But let's don't do that right now. Let's do it now. All right, the antiderivative of that, 2 theta. Antiderivative of that, 9/2 theta. Antiderivative of that, sine, the antiderivative is minus the cosine, so it'd be minus 6 cosine. And then this one is again our kink there a little bit. We're going to have to use the double angle. 1/2 minus 1/2 cosine 2 theta. All right, so we got 2, oh, well, those can combine. 2 theta, that's 4 over 2, so that'd be 13 over 2, right? Theta, believe that? I believe so. Minus 6 cosine theta. And then here 2, 2, so it's just the integral of 1 plus cosine 2 theta. 2 theta. Oh, wait a minute. Hold everything. Forget that. Go back. Because I can't do that. Why not? This has different limits. Unlike before, these are really 2 separate things because I've got different limits of integration. So I can't combine those. That one I'm just going to have to say 2 theta from negative pi over 6 to 7 pi over 6 and then whatever this is. All right. That was going to be bad. Okay, so then this is 9/2 theta minus 6 cosine theta, and then that's 1, so the integral will be 1 theta, and then that's just the integral minus the integral of cosine 2 theta, 2 theta, substitution. D over 2. So that's going to put me minus the integral of cosine of u, 1/2 du. And so we want to go ahead and do that. Let's do it all together. 2 theta, 7 pi over 6 to minus pi over 6. All right, plus 9/2 theta minus 6 cosine. Save myself a little room here. It's 2 over 2, so this would be 11 over 2 theta. Cosine of u is sine, so that would be minus sine 1/2 sine of u. U is 2 theta. And I'm going to go there from 7 pi over 6 to 11 pi over 6. Okay, well, now, plug those in. 2 times 7 pi over 6 minus 2 times negative pi over 6. To these, I'm going to plug in 11 pi over 6. So it would be 11/2 times 11 pi over 6 minus 6 cosine of 11 pi over 6 minus 1/2 of sine, well, 2 times 11 pi over 6 would be 11 pi over 3. And then subtract, plug in 7 pi over 6. 11/2 times 7 pi over 6 minus 6 cosine of 7 pi over 6, and then minus 1/2 of sine of 2 pi over 6 times 7 pi over 6. Okay. So it's just a bunch of numbers now. We got to simplify. Let's squeeze them on there. Okay. It's almost on there. All right. That would be 7 pi over 3. Minus, so it'll be 3. So it'll be plus pi over 3. Nothing cancels there, does it? That's just 121 over 12 pi. I believe. You with me on that? Then I've got 11 pi over 6. So that's the reference angle pi over 6. So I'm talking cosine of pi over 6 is that's your 30, so that would be square root of 3 over 2. And then 11 pi over 6, where's that? That's in quadrant 4. So cosine is positive. That would be minus 6 times the square root of 3 over 2. Now we've got minus a half. 11 pi over 3, so that's 2 pi. And then another 5 pi over 3. Again, we're in quadrant 4, so sine is negative. Reference angle is 60. So that's negative square root of 3 over 2. So 11 halves, so 77 over 12. Pi. 7 pi over 6. Well, that is quadrant 3, I believe. 30 reference angle. Cosine is negative. And sine is negative, but so that's a half. Minus 6 times negative a half. And 7 pi over 3. So that's quadrant 1. Sine is positive there, and it's 60 reference angle. So all told, we come out with a big, long string here. Wow, okay. Putting all that together. Well, put all the pi's together. You got these three, and then you got a minus 77 over 12. I hope that comes out. All right. 7/3 plus 1/3 is 121 over 12, and minus 77. These are all positive, right? Yep. 19/3 pi. Let's see. Well, that's just plus 3, so it's minus 3. And I don't know what happens here. Yeah, that'll be 3 square roots of 3. All right, 3 square roots. All right, minus 3 square roots of 3, and then that'll be positive 1/4 square root of 3, and then that would be minus minus make a plus 1/4 square root of 3. Okay. Minus 5 square root of 3, and then all that's left is this one, which is positive 3, but you subtract it, so it'll be minus 3. I might should check that one. Cosine, talking cosine of 30, just square root of 3. I messed that one up. Yeah. These all should have been square roots of 3 over 2. I should have. So what does that mean? Be minus 3 of that one. Minus 11. Yeah. There we go. That's what I got. Okay? All right. Last one. These are, especially at the end, pretty fun. But good news coming here. Need to talk a little bit of arc length. Arc length for the polar curve. If you have a polar curve, r equals f of theta. Turns out it's pretty nice. You know, the way we did a lot of these was change it over to parametric. Well, same sort of thing, but it really turns out nicely. To be this. Arc length in polar form, well, it's r squared plus dr d theta squared, the derivative there of your function. Call it dr d theta or f prime of theta, whatever you want to call it. Square that and then square root both of those when you add them together. And then your d theta. That's all you have to do. So let's do one of those, and we'll call it a day here. Find the arc length of r equals 4 cosine theta from 4 theta's between 0 and pi over 6. Okay, well, easy enough. We're going 0 to pi over 6, so that's my a and b. Square root, so I'm going to square root the r. Square root the r squared, which is, this is r. I'm going to square that. Dr d theta, well, like I said, all that's wanting is the derivative of whatever your function is. So dr d theta, you don't have to go parametric or anything like that, just wanting the derivative of r with respect to theta, so it's just the derivative of that, which is negative 4 sine theta. And hey, look at that. That's going to be nice, isn't it? I think so. Here's what we can do with that. Of course, that can get really complicated pretty quickly, but this one works out pretty nicely. That'll be 16 cosine squared theta, and that'll be 16 sine squared theta. And so this one turns out very nice. Because if I factor off 16, what happens? Yeah, that'll just be 1 times 16, won't it? Factor off the 16, we've got cosine squared plus sine squared. Cosine squared plus sine squared is just 1, so we've got the square root of 16 d theta, which is just 4 d theta, which is the antiderivative 4 theta. I'm going then from 0 to pi over 6. So that winds up being 4 times pi over 6 minus 4 times 0. So that's 4 pi over 6. That is 2/3 pi. So the arc length for this, I didn't even graph it, did I? For cosine theta, what does it look like? Yeah, it's well, best I can tell, it's something kind of oval like that. But, so from 0 to pi over 6, that length right there is 2/3 pi.